you know, these first two sections, right? First three sections. If we need to draw a picture, but coming up with the equation, the model that we want to take, optimize means taking the derivative of used to find, and I'm just gonna write f prime as a shortcut for derivative. And so those are the things that we started with, and these notes really are simply an extension of that, okay? And so in fact, if you take a look at it Friday, we spent some time reviewing, you know, the distance formula and then saying, hey, we've got this distance, what's the shortest distance between this point and some point here? And I said it rather than write y, I think we just said, hey, that point could be expressed as x comma square root of x, since y is equal to the square root of x. Are we okay with that? And then we came up with an equation that looked like this. D of x, that distance right here, can be expressed as the square root of x minus 5 squared, and I think we had the square root of x minus 0, the square root of x minus 0 was the square root of x, and then we squared it and we came up with something like that. Am I correct? So depending on what x is, wherever x is, if it's way over here at 1 or at 2 or at 3 or at 4, we could plug it in and use this equation to figure out that distance, okay? In fact, if I did plug 4 into here, I'd have 4 minus 5, which is a negative 1. I would square it and get 1. Then add 4 to that 1 and get the square root of 5. So I could say when I'm at 4, the distance is the square root of 5. Everybody okay with that? And so we want to optimize this by making it the smallest distance. So what we're going to do is I'm going to first rewrite this. And the reason I'm going to rewrite this is I'm going to take the derivative of it. And you could, if you wanted to, expand what's in here and take the derivative of it. Okay, or you can take the derivative and then use the chain rule. That's the method I'm going to use. In both cases, you would have to use the chain rule. All right, so it's going to look like this. I'm going to have 1/2 parentheses x minus 5, and my voice is starting to die, plus x to the negative 1/2. Is everybody okay with that? That's just the outer derivative, right? Now I'm going to come in here and take this derivative, so I'm going to have times, and I'm going to have parentheses, and I'm going to have 2 times x minus 5. This will go to the first power. I'll come inside these parentheses and take the derivative of x minus 5, which is simply 1. Plus, I had this plus x. So the derivative of x is going to be what? 1. So I have this. Would everybody agree?
I think so.
Okay. So now I'm going to rewrite this. And down here, I'm going to have 2 square root x minus 5 squared plus x. And up here I'm going to have 2 x minus 5 plus 1. And I can write that as 2x. If I distribute, I get 2 times x, which is 2x. 2x minus 5 is a minus 10 plus 1. All this has to be done together. I can't simplify the 2's here because what's saying on top is make sure you take 2 times this quantity and then at the end add 1. That's what it's saying. And so that gives me 2x minus 9 on top, and it gives me this at the bottom. I'm gonna raise it up a little bit so you can see that. Is that easier to see, Owen, if I raise it up a little bit? Okay. Now, so this is the derivative, correct? And the critical points, the critical x values come from two places, both the numerator and the denominator. So the numerator, what I'm going to do is I'm simply going to take 2x minus 9, make that equal to 0, and I get x to be 4.5. And if I take the derivative of this 2x, the second derivative would be 2, correct? That's greater than 0, correct?
Let's see.
Oh,
Where'd you get the?
this should be a D.
Where'd you get that? Is 2?
I took the derivative of 2x minus 9
Oh,
and got 2. And that's greater than 0, so that means it's concave up, and that means that x minus 4.5 gives me a minimum value, correct? Now, unfortunately, the other place that I could get a critical number is in the denominator, correct? And so I'm going to make what's inside this square root equal to 0. Everybody okay with that? All right, so I'm going to do it here in the margin. And I'm going to write x squared minus 10x plus 25 plus x. So where did I get that x squared minus 10x plus 25? I just expanded this x minus 5. And that's going to give me x squared minus 9x plus 25. Now, if I was to use a calculator, I would graph that, and I would see that it does not cross the x-axis. So there, you understand? Sometimes those parabolas could be above the x-axis, right? And so there are no solutions. Everybody agree? Now, if I couldn't use my calculator, I could use this, and I use this a lot.
what does that say?
B squared minus 4AC. Has anybody ever heard of that? It's from the quadratic formula. It's the stuff that's inside the radical, correct?
I forgot
It's
the
called the
quadratic formula.
discriminant. Does everybody, it's not, you won't need to know that, I'm just telling you, it's an easy thing that I apply. The only time you have solutions is if the discriminant is greater than or equal to 0. That's the only time.
I have no
If
clue what
it's
that means.
negative, that would mean it's negative inside that square root, correct? Which you can't be. So here, this is B. I have 81 minus 4 times 1 times 25.
Where'd you get that?
A, B, C, correct?
Okay, so 81.
B squared minus 4AC is the thing that's inside the quadratic formula. It's called the discriminant.
I have no clue what I forgot the quadratic formula, to be honest.
I got a little story to tell.
And
So-
what happened to, oh, because it's not B of x, so it's not 81x, which is why there's no x in there, correct?
I'm just using the coefficients.
Oh,
That's the quadratic formula.
yeah, I'm gonna.
Have I told you my story about the quadratic formula? So I'm a senior, we're math geeks, okay? And you know, you start out as a freshman, you got, I don't know, 40 people in your class, and you're a senior, now you have 10, okay? And we had to somewhere memorize the quadratic formula, because we didn't have a calculator, we have a slide rule. So we said, okay, every time somebody can yell out at you anytime, what's the quadratic formula? And you'd have to say it, if you didn't say it, you put $1 into the pot, and then at the end of the school year, we would go out like to Perkins and have something to eat. Does that make sense? So, you could be in the huddle of the football game, and the star running back says to you, Kruger, what's the quadratic formula? And you had to say it. Otherwise, it's going to be $1. Or, they would see you walk in the bathroom and yell out, Kruger, what's the quadratic formula? Or you might be at a dancing, and somebody would yell at you. Okay. So anyway, I got to know that really well. But right here's the discriminant. So when you see that here, this is 100, correct?
Mm-hmm.
That's 81 minus 100. It's negative. So there are no solutions for this, so that's the solution. And if I wanted to know what the distance was, I would put 4.5 into the distance, and I would get the square root of, well, I would put 4.5 into here. That would give me a negative 0.5, but when I squared it, it would give me 0.25 plus 4.5, and so whatever the square root of 4.75 is my smallest distance. That's my minimum value. Are you okay with those terms? Because we've used those terms for a while?
I think I get it now.
Okay, good. All right, so let's talk about this one. This one was one we had these two towers. And the two towers looked like this. One was 28, the other one was 12. We had a stake here, went like this. I think we called this X, and this 30 minus X, and there was a wire coming down here, correct? And then we said, okay, our function for the wire was the square root of 28 squared plus 30 minus x squared plus the square root of 12 squared plus x squared. And we use the Pythagorean theorem to come up with those. Okay, now, you're going to see me use the domain in this case. Obviously, 0 isn't a good choice, correct? Can it go to infinity?
No, it can go to a max of about 30.
Why?
Because if we go above 30, we'd have a negative amount of distance.
Would everybody agree? Okay. So I know our answers have to fall in here, correct? All right. So I'm going to take the derivative of this. And down here, I'm going to get this. Would everybody agree?
I have no clue.
Well, that's a square root, correct? This thing has a power 1/2. So I'm going to multiply by 1/2, and I'm going to subtract 1. That's going to give me a negative 1/2, which simply puts the square root in the bottom. We've done that several times, correct?
Okay, I think I get it now.
And now I'm going to take the derivative of this inside and put it on top. The derivative of 28 squared is what? 0. So now I'm going to have 2 times 30 minus x to the first power. So I'm taking the derivative of that times a negative 1. Because the derivative of a negative x is a negative 1. Okay?
I am not 100% sure, but okay, I'm just gonna go with it.
Well, I had 30 minus x squared I take the 2 times this coefficient, which is 1. I have 30 minus x, I drop 1 power, and then I come in here and take the derivative of that.
Oh, I think I get it.
Okay, so now it's gonna simplify to a negative parentheses, 30 minus x over, because I can get rid of these 2's now because I'm multiplying, the square root of 28 squared times the quantity 30 minus x, that quantity squared, which is the same as this. All I did was distribute the negative 1. Okay, this is gonna look the same thing. Down here, I'm gonna have 2 square root of 12 squared plus x squared. And then I'm gonna take the derivative of this on top. The derivative of 12x squared, it's a constant, so it's going to be 0, correct? And the derivative of x squared is what? 2x. And I can simplify those 2's. So down here I have plus the square root.
Just a quick question. How are we getting the numerators?
Those are simply the derivatives of what's inside the square roots.
So derivative of something inside square root becomes the numerator?
Correct.
Is that always the case?
Yes.
So in taking the derivative of something of a square root, we end up turning it into a fraction.
Correct.
And when we do so, our numerator will be the derivative of what's inside said fraction. Said
All the time.
Okay. I'm just trying to see how to apply that in my head, right, real quick.
Right, and what I can do is I can show you something like this. Let's say I have the square root of 3x plus 9. Okay? And so that's 3x plus 9 to the 1/2 power, correct?
Yeah.
Its derivative is going to be 1/2, 3x plus 9 to the negative 1/2 times 3.
So you're gonna get 1 over, so you get 3 over 2. Yeah, I get it now.
Does that help?
Yeah, I get it now.
Okay.
Thanks.
Yep. All right. So what I did, I'm going, oh my gosh, that thing is terrible. So I said, hey, I would always give this as a calculator problem. And so I'm going to put this into my graph. And I'm looking for where it crosses the x-axis. Everybody okay with that? All right. So I did that already. There's that equation. If I came up here, you can see here's the first part. Oops. And there's the second part. Everybody have that? And then I drew it. And that's the derivative, correct? This right here is the critical number. Would everybody agree? It's an extrema. How do I know it's an extrema?
And it's the relative min.
How do you know that?
Because it's going from negative to positive.
Because it's going from negative to positive. If it did not cross, it wouldn't be. So I know this is already a minimum value. And since it's the only one, it's an absolute minimum value, correct? So I went to, you guys know how to do it on TI, right? To find the solution. You go a little bit to the left, a little bit to the right, and then you press, do you want to guess? No, and then you press enter, it gives it to you, right? Okay, so this, all I have to do is say, hey, do you want the answer? Yeah, I do. And it's 9. Okay, so x equals 9. And so on this side, it would be 21. And I could put 9 into this equation up here to figure out what it would be, right? How much wire I would need. I would figure out, okay, it says where should the stake be placed? Well, it should be for the least amount of wire, it should be at 9. It doesn't ask me for what that value is. Are we okay? All right.
Okay.
Now, on the back, it should look like this. Am I right?
Mm-hmm.
And so what I did, I said, okay, let's go back to this problem. And this problem was number 1, where it said you have two numbers whose sum is 30, and the product you wanted as large as possible. So we said P was equal to the product. This is what we want to optimize. And then we said, well, P of X would be X times replaced Y with 30 minus X. And then we got this. This should be the notes I gave you on Friday. Everybody okay with that? And so what I'm going to do, this is what I'm going to take the derivative of. So over here, here's number 1. I have P of X is equal to 30x minus x squared. I take the derivative of that. I get 30 minus 2x, make it equal to 0, and x is equal to 15. Then what I did to prove that this is the minimum value is I took the derivative and got a -2. Oh, excuse me, this is a max value. Remember, I'm trying to find the max. So what does that mean? That means I'm concave down. That means that's my absolute max. So if x equals 15, and you have 30 minus 15 for y, y has to be 15. So my max value is going to be 15 times 15, which is equal to 225. So if I have two numbers whose sum is 30, the maximum product they can get is 225. Okay? All right, the last one, because I know you'll see this one again for sure. It's almost on every quiz I give and every test I give. So we had this rectangle. This was number 3, where it was 30 this way, 14 this way, and then I cut out little squares. And I ended up with a rectangle that looked like this. Where it was x high, this was 14 minus 2x, because we were taking off 2 chunks on each of these sides, and over here I had 30 minus 2x. Everybody okay with that? And then I asked what volume was, and somebody said that's length times width times height. And we got a volume, I think, of 420x minus 88x squared plus 4x cubed. That should be in your notes from Friday.
Wait, isn't height x?
Yeah.
Okay, I think I get it.
I took and multiplied all these out.
Oh,
If you look at your notes on yeah, these are the notes that we did on Friday. We ended up as that as the answer. So I'm just recopying it. That's all I'm doing. Okay?
We
So-
take the derivative of that.
I'm gonna take the derivative of that. Notice I'm doing the same thing. Once I get that, I take the derivative of that. And I make it equal to 0. And I wrote it in this form.
But wait, isn't that a two?
Second term isn't derived.
I did something wrong?
Negative 88 times 2.
Oh, yeah, 176. Thank you. And that's why I have it in my notes too. And then what I did is I divided everything by 4 and got 3x squared minus 44x plus 105. This was factorable. And I got 35 here, and 3 here, and I got 3x is equal to 35, x equals 11 2/3. Here I got x minus 3 equals 0, and x equals 3. I got 2 answers. However, if I have the domain, obviously I can't have 0. Can I have any size that I want? No. What's the maximum have to be?
7,
Where do you get 7 and why is it not 15?
because it's the length of the short side divided by 2.
Right, would everybody agree? As soon as this is 7, this becomes non-existent, correct?
Yeah.
So you have to take the shortest side and make that equal to 0 and say, okay, that's going to be the top end of my domain. Everybody have that? Otherwise, if I had chosen this one would work, but it makes a negative number here. So my domain's in there, so x equals 3 is how much I would have to take out. Okay, all right. The last problem I want to do is this one right here. It says, a particle is traveling along an x-axis and its position from the origin can be modeled by. So this is a position function. And so it says on the interval from 3 to 9, so notice that this is a closed interval. Find when the particle is farthest to the right. So we're looking for the absolute max on the position. They can only occur at 2 spots, the endpoints and where else?
Critical points.
The critical points. They already gave me the endpoints, correct? So what I did is I put into X the number 3, and I had 27 minus 15 times 9, excuse me, 15 times 9, whatever 15 times 9 is, plus 70.
135.
What is it?
135.
135?
Yeah, for 15 times 9.
And then 72 times 3 minus 9, and I got 99. And then I put 9 into there, and I'm not going to write out the numbers. I got 153.
So far x of 9 is our max.
So I took the derivative, and since it's a position function, Ben, its derivative has to be a what? It's a requirement. It's a physics requirement, actually.
Positive.
Nope. Anytime you take the derivative position function with respect to time, you get
Oh, velocity.
velocity function. Well, and I know you were trying to send it to him telepathically, but he wasn't focused.
Nope, it's Monday.
It's a Monday. That's absolutely correct. So what is the velocity function here, Ben?
Derivative of
Yeah, what is it? Here it is.
3t minus 30t, oh, sorry, 3t squared
Minus
minus
30t
80t. Yeah,
plus
plus 72.
72. And I made that equal to 0. And then I divided everything by 3. We got t squared minus 10t plus 24. And I factored, and I got t minus 4 and t minus 6. So that means I put in to x 6, and I put into x 4. And when I did that, when I put it into 4, I got 103. And when I put 6 into there, I got 99. So when is it furthest to the right? What?
9.
T equals 9 seconds. Last one. Are we doing okay? All right. We want to know the maximum speed. What is speed in terms of mathematics?
Velocity.
What a velocity.
The absolute value of it. So since it's trying to find that, we gotta find the acceleration, find the critical points of it.
Okay? So when you want to maximize speed, you always take the derivative, correct? So like what Matthew said, we're going to find the acceleration because that's the derivative of velocity.
T equals 5. That's a
Okay,
critical
you're
point.
going a lot faster than my brain, okay? So slow down a little bit.
Hey, hey, give me some credit. This is the only thing I'm really good at right now.
So what is Callum, what is the derivative of this thing right up here?
6t minus 30.
Minus 30. And like what was sent across the airwaves, that t equals 5. Now, how do I know that's a maximum? Well, it doesn't matter, does it, whether it's negative or positive, correct? So I'm going to put that into the velocity, correct? The absolute value of t equals, I want to put a 5 in here. And I get 25, actually I don't get 25. I get 3 times 25, I get 75, minus 150, plus 72, and what do we get? 45? That doesn't look right, does it?
-3, so we get 3.
Where'd you put it in?
75 minus 150 plus 72. We get -3, aka speed is 3.
You get 3 as the max.
Feels weird.
Okay, but where else can it be? It's on a closed interval, correct? So I still have to put, I just put 5 in there. I also got to put 3 in there because it can happen at the endpoints, correct? And so when I put 3 in there, I'm gonna get 27 minus 90 plus 72. And what do we get there?
9.
9. And then when we put the other endpoint in there, 9, we're going to have 3 times 81 minus 240? No, 270. Plus 72. What is that?
45.
45. So the maximum speed is 45. What is it going? Does it tell us our units? Centimeters per second. So you always have to look at the endpoints too when you're on a closed interval.